Hello everyone. Now we are going to discuss one more important topic from our 10th class, Ohm's law. In 10th class annual examination point of view, this Ohm's law is very important. Okay, we have an activity. So I will explain as activity, then aim. What is our aim? To find the relation between V and I. V and I. V means potential difference and I means current. Next, materials required. What are the materials? Then we required 6 holes of cells, then each one 1.5 volts. Each cell contain 1.5 volts. That means take 4 cells which contains 1.5 volts, and ammeter to measure the current, voltmeter to measure the potential difference, and switch next one iron spoke. Okay, iron spoke and LED bulb. LED. These are the materials we required to do this activity. Procedure. In the procedure after we will get diagram. Then here take a connectors, that means copper wires, and take a iron spoke first. This is iron spoke. Okay, and connect this iron spoke with a wire, copper wire, and a battery, and ammeter, and a switch. Okay, and arrange, connect voltmeter across the 2 points A and B. This is a way we have to complete the circuit, right? An ammeter is connected in the series connection, then voltmeter is connected to measure the potential difference across a conductor at between 2 points, right? This is the procedure to arrange the equipment, and this is the diagram, right? And after observation, to note down the observation, we have to write the observation V and I and V by I. Take a table and first connect the single cell and switch on the bulb. This is now open circuit, so current will not flow. Then close it, switch on the circuit. Then current is flows. We know that current is flows from positive terminal to negative terminal in this direction. Okay. Electrons can move from negative terminal to positive terminal, opposite to the direction of electric field. See here, when I have connected with one cell, then potential difference is 1.5. Okay, volts. When 1.5, then ammeter is gives the reading of current. For example, it is given as 3. Next, I have connected one more cell. Okay, right. Now it becomes 3. Why? Because this cell contains 1.5 volts. And current we get 6. And next I have arranged one more cell. Okay, then 4.5 and 9, and one more 6 and 12. These are the readings we get it. These are the readings we got while doing the experiment. Simply I am connecting one by one cell to the circuit, and I am measuring I am recording the observations. Then V by I. Here from these observations, one thing we have noticed it. What is that? When it is potential difference is 1.5, we get current 3. When potential difference is 3, we get 6 amps. When 4.5, 9, 6 and 12. Then here one relation we have noticed it, that we have to write as a conclusion. What is that conclusion? Is always V is directly proportional to the I. V is directly proportional. See, potential difference is increases, current is increasing. Potential difference is increasing, current is increasing. This is the relation we have noticed it. Then the Ohms says that finally by this activity he came to know that, and he concluded that the potential difference at 2 points is directly proportional to the current. Potential difference across a conductor is directly proportional to the current. This is the conclusion is given by Ohms. Okay, this is Ohm's law. And here finally while finding the V by I value, so 1.5 by 3, that's equal to 1 by 2, that means 0.5. Here 3 by 6, that's equal to 1 by 2, so 0.5. And 4.5 by 9, that's equal to, we will get 0.5. And 6 by 12, we will get 0.5. See here we got a constant value. We got a constant value. So always, and one more, V by I equal to constant. V by I equal to constant. This constant says the resistance. Here he has given the relation V is directly proportional to I. So I want to remove this proportionality symbol. So I should keep one constant. No, that's equal to I, or instead of this proportionality symbol I have written or. So V equal to IR. V equal to IR. Potential difference is equal to product between the current and resistance. Current and resistance. R stands for resistance. Okay, R stands for resistance of a conductor. Which ones? These ones. Resistance. It gives a resistance. So how much its resistance are here? 0.5. At this case, this iron spoke's resistance is 0.5 from this observation. From this mathematical principle we can able to know it. So we can write V equal to, here like V equal to IR, right? Or so if you want to find I equal to V by R, and R equal to, it becomes V by I. R equal to V by I. So what are the units of resistance? Here we know that what is the unit of potential difference? Yesterday we discussed that potential difference units are volts and current units are amperes. 1 volt per ampere equal to 1 ohm. What we call ohm. So this unit also given on the honor of ohms, on the honor of the scientist only. So what are the units of resistance? What are the units of resistance? The units of resistance is ohm. Units of resistance is ohm. Okay. 1 ohm equal to 1 ohm is defined as 1 volt of potential difference is directly proportional to the current. Okay, so R equal to V by A is, this is a way to we can find the resistance of a conductor. And here we then try to, then while using this data, I have drawn a graph V and I, potential difference and current. So on x-axis I have taken potential difference and y-axis I have taken the current. So take the value scale as 1, 2, 3, 4, 5 and 6. Here 3, 6, 9, 12. Okay, then use these values which we got here. Here potential difference is 1.5 for example here. So current is here and 3 volts then at 6 amps. 3 volts means 6 amps. And next 4.5 we got 9, right? At 6 we got 12. So join all the lines, we got a straight line. Use scale while drawing this graph, then you will get straight. Okay, here I am not using a scale, no, so maybe a little bit slightly bend the line, but actually we will get a straight line. So this is straight line. So instead of this iron spoke, here we have taken one more thing also. What is that? LED. So instead of that we use LED bulb. Sir, we will then again do it the same process change the cell and increase the potential difference in the circuit and measure the current and note down the observation in a given table. And after using that given data, then try to draw the graph for that. Then we will get the graph line as this curved. See, here we got straight. In this case we got a straight. Here curved. In case of LED we got this. In case of iron we got this. Right? So based on that graph, based on this concept, the materials are classified into two types. Materials are classified into two types. Those are as ohmic substances and non-ohmic substances. This is ohmic substances. These are non-ohmic substances. Sir, for ohmic substances, we will get the graph line is straight. We will get the graph line is straight. For non-ohmic substances, the graph line we get curved. Okay, right. So ohmic substances are all metals. Then what are the ohmic substances? Means the substances or the materials which are obey the Ohm's law. The substances which are obey the Ohm's law, those are called as ohmic substances. Almost all metals or ohmic substances. Okay, the materials which are not obey the Ohm's law, those are called as non-ohmic substances like LED and semiconductors. Okay, or the non-ohmic substances. Right? Here in ohmic substances, we will get we will get a straight line in a graph. In non-ohmic substances, we will get curved line. So this was the complete brief information about the Ohm's law. Okay, right? Thank you.